Okay, so Module 6 is actually our last module, so hooray for that. This is going to be our last module in Workplace Math 10. There are 8 topics that we're going to cover in Module 6. So Module 6 is, oh, I don't have it up here, but I'll just write it out. So we're looking at trigonometry, and specifically we're going to look at right-angled triangles. So right-angled triangles, I'll explain a bit more what I mean by that. Or you might already know what I mean by that, but we're not going to look at anything other than a right-angled triangle. Triangles. Okay, so there are 8 topics. We're going to go through labeling a triangle, looking at the Pythagorean theorem, Pythagorean triples. So this will probably be what I cover in this video just because it all goes together very well. So 6.1 to 6.3 I usually cover together, and that's what I'll do in this video. And then we'll look at actual trigonometry and looking at the ratios. So this is going to be where you learn, or we learn again, depending on if you've done this before, about SOHCAHTOA, which is very important. We're going to look at finding the side lengths in right triangles, angles of elevation and depression, and then finding angles in right triangles. And that's all. So when we're done this, we're going to be done. Hooray! All right, so let's start with 6.1 today. And 6.1 is looking at labeling a triangle, and we're going to talk about labeling a couple different ways. Sorry, let me just fix something here. Okay, so we're going to look at labeling more than once, but today's labeling is going to be just in general. But we're also going to look at labeling triangles in a few sections here. Section 6.4, I think we'll start looking at specific for right angle trigonometry. Okay, so it's a little bit different. I'm just going to call them R angle. Okay, but this is just looking at labeling triangles in general, and this whole section, and when we look at specific for right angles, this is very important. Okay, because if you cannot label the triangle properly, you're not going to be able to do the math. So learn this, focus on this. Just because we're looking at labeling, don't think that it isn't important, okay? Oops, that's not an exclamation point. It is very important. There, learn this. All right. So there are conventions, which just mean there are specific ways that things are done by everyone who deals with triangles. And there are conventions when we label a triangle. So we're going to use some uppercase letters. Okay, so all uppercase when we are labeling the vertices, and that is a fancy way for saying corner or pointy bit. It is a triangle. Tri means 3, right? Triangle, tri means 3 equals 3 vertices. All right, so there will always be 3 vertices because we're dealing with a triangle. And that would, if we're looking down here, we've got, sorry, let's just look at our triangle. We've got 1, 2, 3. And I'm just going to use A, B, C, but they could be any letters. They could be C, D, E, E, F, G. It doesn't really matter, okay? But A, B, C is what we're looking at here for our vertices. And I'm just going to, maybe what I'll do is take color. So these are our vertices, which are the corners, okay? So A, B, and C. Lowercase letters, oops, and I realized here, uppercase case, we don't need that twice. Lowercase, so that's little letters, are used to label the sides. So what we do is we take the side opposite the letter. So a side always has the same letter as the vertex. That's one vertice, that's a singular, as the vertex across from it. And sides can also be named using the 2 vertices, and this is going to seem strange, the side connects, but I'll explain in a second here. So let's do this just for a sec. I'm just having a look. Sorry guys, I'm just trying to find. Sorry, pause. Okay, no, I found it. All right, so let's look at this. Okay, so we've got our vertex A, okay? Now, side A is going to be the side that is across from the vertex A, okay? So this is the side little a. Another way that we could talk about or call that side is we could call it side BC because it's in between side B and side C. All right, and let's just change the color here. Sorry. Hey, come here. Let's do green because I like green. Okay, so we're labeling the sides here. All right. Side C is going to be directly across from C, so side little c. And we could also call this side AB because it's between vertex A and vertex B. Okay. And then all the way over on this one, we've got side little b, which could also be called side AC because we are between vertex A and vertex C. Okay? So that's how you label a right angle triangle there. Let's just see here. Okay, so while regular lowercase letters are used to label the vertex, the point where two line segments meet, okay, so the point where two line segments meet, what am I talking about here? Two line segments meet. So the vertex is the pointy bit, but right in here is what I'm talking about when I talk about the point where two line segments meet, okay? So right in there. We use Greek letters often, not always, but Greek letters are often used to label the actual angle. When used in calculations, regular letters represent a length, so a length, and Greek letters represent the size of the angle. And right now we are looking at the size of the angle measured in degrees for this course. And this is important because there are other angle measurements you can use, but we're only using degrees. And I butchered the writing of degrees, so let's do this. Oh my goodness. Measured in degrees for this course. So we have theta, that's the first symbol. This is alpha. This is beta. And this is gamma. And so these are four different Greek symbols that we often use to represent an angle. So if we have any type of triangle, but in this case I'll draw a right angle triangle, for example, and you have side A, side B, side C, you might have angle here, theta, okay, so angle theta, sorry that's angle theta. You don't have to put the quotations, but I'm just showing you. Sometimes though, and I just want to make sure that you know this in case you see it, sometimes we will keep the letter, so it'll end up being referred to, sometimes referred to as angle C, okay? But this is the internal angle that we're talking about. And I should actually write internal because that's important. Internal. Oh my goodness, I'm having to rewrite everything today. Okay, internal angle theta. One special triangle we often use is the right angle triangle. Okay, so this is the triangle that we'll be only using from now on, and it has a right angle, and a right angle is 90 degrees, okay? The side opposite the right angle is always the longest side, so that's really important, of the right triangle, and it's called the hypotenuse. You won't get marks off for not being able to spell this. I misspell it quite frequently. But hypotenuse or hippopotenuse, if that helps you remember. And then the other two sides are called the legs. And only a right triangle has a hypotenuse, but we're only going to be using right triangles, so that's fine. So if we look at this right triangle, it's the side that is opposite the right angle. So this is our 90-degree angle, which is the right angle. Okay, this is going to be our hypotenuse. And if you look, visually you can see that it's also the longest side of all three sides of the triangle. And then you have two legs. You've got leg 1 and leg 2, and it doesn't really matter which one you call leg 1 and which one you call leg 2 as long as you're consistent with that, okay? So yeah, just make sure you're always looking and you're always making sure the hypotenuse, that's not how we spell it, and I even mess it up all the time. The hypotenuse is always across from the right angle. Okay, so 6.1, labeling triangles. Please do all of these. I will post, the key for this will be in the notes because I don't really have a key specifically for this part. So key in blank note package. Or sorry, not in blank, in filled note package. Okay? All right, so start there. And we'll then move on to 6.2.